Good morning. My name is Stan Bissinger, and I've been asked to add to or continue on with this discussion about geothermal energy. Um, and I'm going to start by um, putting up this screen. I've discovered what the deal is with PowerPoint, by the way. I should just make a discussion about this, is that the reason why it's so hard to get the F5 key to work with PowerPoint is because when you do that, it jumps to your other screen. Okay, the image that your presentation is on goes to the other monitor. So what I'm going to do is just leave it on this monitor so I can have control over it. This was a slide that I used last time, so I'm going to just review this very quickly. If you were to look at the Earth from the satellite, and you were able to see underneath the Earth where all the geothermal spots were, everything here in yellow to dark red is where there's actually very active geothermal activity going on. So geothermal, which really was, I think in the early 1900s, it was discovered. The first one was in Tuscany, Italy. But the more recent ones that were done in the 50s and the 60s that were using, you can see here, Iceland uses a lot of it. And there's a lot of that. It's always been available, relatively easily available. For example, there is a geothermal unit that was near the Salton Sea in San Diego. I'm going to talk a little bit more about that. That's a new technique that's coming up. So the geothermal that I'm going to be talking about today is going to be more about recently developed geothermal techniques that go beyond just the surface quality of heat that's available, but more heat that's down available. I mean, it's obvious that there's two suns involved in our discussion here. There's the one out there in the middle of the solar system, and the other one that's in the center of our planet. And the idea of borrowing some of that energy to supplement our needs is very attractive.
How do you want to handle questions, Stan?
Carol, go ahead. I can take care of that.
This looks to me exactly like earthquake zones, places where tectonic points are shoved up against one another and giving us earthquakes.
No doubt.
Reason for that?
Bangkok is, well, I would say that wherever there's fracturing, if you look at the fault line here, it's the San Francisco area. There's got to be tectonic plate action, which allows for fracturing and that kind of activity. I mean, I'm no geologist to be able to say for certain what's going on, but it would seem to me that wherever you have a slippage of the tectonic plates, the opportunity for pressure, magma, and so forth would be capable of getting closer to the surface.
Okay.
David.
Yeah, and it also depends on what the situation is with water, because the early ones were basically steam coming to the surface from the geothermal heat close to the surface.
Well, there's going to be two components that we're going to talk about, and I talked about this last time. I'm going to go ahead and just discuss this. we did talk about this more extensively, so I'm not going to show that many videos from Cindy Taff this time is around, unless we get done. There's at least 3 videos that I definitely want to watch before I get back to that. But there's the Sage Geosystems, which is the break off from Exxon Mobil. Cindy Taff developing this company that's going to go underground for hydropower. And she emphasizes the use of both the pressure and the heat. So pressure and heat both are parts of this process to turn turbines either with steam or with just water pressure. And they have 3 different levels of this. They have the single hydropower, turning fractured rock into a balloon technology. They have the heat cycle where you drill a long row of wells. I think there's wells of wells that are, I think, 10 feet apart from each other. And then they start to communicate with each other, and that gives you it multiplies the output. And then they also talk about using the inverted, she calls it the inverted water tower, where you're putting water, pressurized water, just like you would take water and push it uphill. And then during the time that you have more power coming off solar power and wind power than you're using, and then you're basically allowing that water to come back down the hill for hydropower to create power. She claims that you can do the same thing in the ground by pumping water down into developing, and that the ground actually swells and creates a springy like breath, like a lung. And when you want it to, it'll extract, and that pressure will come back and turn generators to create more power. Next along, today I want to get to this. David made a special request. There's Quaise Energy, which has a huge device using microwaves that was originally designed for enhancing fusion reactors, not fission, but fusion reactors, tokamaks. And they discovered that same device was a pretty nice tool for digging down through rock. And so they're trying to transition that technology for geothermal enhancement. We'll get to that a little bit more later. I have a video on that. Now this is Fervo, which is going to be your traditional fracking, oil company style fracking, where you push water down on one side, and then the hot steam comes up on another side and turns a turbine to create power, and that condenses and comes back down into the other side. Now, one thing I recall that Carol mentioned last time when we did the discussion is that this is going to be water intensive resource, and that we don't always have lots of water in certain locations. And I think what you need to understand here is that this is a closed loop system as far as water is concerned. So it's not an infinite amount of water, not necessarily an infinite, but you don't have to have a constant supply of water to make this work. It's going to probably be a pool of water or some kind of a reservoir of water that can be used in a constant water situation. So even when we get to the closed loop, and this is the closed loop, is this one right here, which is also a different company, but they use an actual concrete barrier. It's not an open fracture, but they have a tubing that goes down, and you can see it forks down. It starts blue and it comes down, and these are on the top, if you will, of the fork, and then it comes to a point, and then it's returned back on another loop. And this is concrete tubing all the way down and concrete tubing all the way back. So it's what they call a closed loop system, which has no potential for deforming or causing earthquakes or bringing up any kind of unwanted water situation into drinking waters and so wells and so forth. The penalty here is that the heat transfer is not as good with this as it is when you're pushing liquid through fractured rock. I think I saw, and this might come up in the video, a 10x improvement in the level of intensity of the heat that you can get, which obviously gives you more power. Now I'm going to be watching we're going to be watching a Sabina Hassenfelder video. I think I want to do her first, and she'll bring up the Zenkar company, which is just using AI and all kinds of data from satellites and any source of data they can possibly get their hands on, and trying to come up with a strategic method for determining where it's good, what good locations are, where locations are for good geothermal production. So it's basically that discovery and exploration side of the equation. Now this is the new part. David sent me this the other day. There is a interesting caveat with this. For example, this is the Elmore geothermal plant. I'm surprised I don't have Dean here with me today. From near San Diego, California, and there's a huge lithium area near San Diego called the Salton Sea that has a huge quantity of not only lithium but other rare elements that can possibly be valuable in terms of extracting. And I'm going to be re-looking at a couple of videos regarding an idea that is new, that I think is new, relatively new anyway, where you can use a process that not only extracts the geothermal heat from a geothermal situation, but also will be able to extract the lithium from the water from that as well. And so you'll be extracting the lithium out of the water, and the water goes back into the system for the geothermal. And so you get two benefits. You get geothermal direct output, and you also get a incredibly high quantity of lithium for production in batteries. And then the last thing that we did last time, some of you will remember, is that there was a company called TS Conductor that had a 3x times better transmission capability for our grid. And I felt that was appropriate to talk about that, because that was something that I think any power discussion about power and energy, electrical power and energy, if you dismiss the grid, you're missing the effect of being able to transmit power to wherever you need to get it from and where you need to get it to. And as a European friend of mine once said, my God, there's a lot of space between your cities here. And that's true for the grid as well. There's a lot of transmission that we have to do compared to other areas like Europe, for example. Any questions so far?
Yeah, I have one.
Go ahead, Tom.
Talking about that, the transmission wire you just showed, it's aluminum coated, has 3 layers. it sounds very expensive, and it's also aluminum's not the most is not the cheapest thing to mine and refine and so forth. So, what are the actual economic prospects for something like that? It doesn't seem very feasible compared to what we're doing.
Well, I had a video on that, and it was a TED Talk. That's about all I know about it. And he was making it sound like they had come up with they had already done some. This isn't the one that was superconductor. There was another transmission company that was coming up with a way of putting refrigerant into the lines so that you could get something like a superconductor style performance. But I think that their argument, we could watch that video again if you want. Their argument is that it was relatively affordable. Speaking of using the word relatively. What I'm going to do right now is I'm going to post my, I'm posting my doc file that I'm using for my resources into the chat. So if you want to have that, you can have that.
Yay.
So I'm going to say I don't have the numbers on that, Tom, as far as but I think that the idea that you can, it's more future oriented, and it's 3x the improvement in power and voltage and so forth. I think that the one thing we had concern about was that it was going to be so hot, the cables are going to get so hot that it was going to be toasting birds' feet was the issue that came up last time. But
Well, and starting forest fires.
possibly, yes.
Yeah, because in California, a lot of the utilities turn off the power in order to prevent forest fires when there are high winds.
Well, this is not going to the thing that they came up with, and I see Dean's on this now. The thing that they came up with is it's not going to sag, and it's not going to have the waving of the cables as you say I have with the current power lines. But as Tom Trice pointed out last time, is that it may have a different frequency of vibration. It's like a guitar string. The tighter you tune it, it's going to have a higher frequency.
Right, that's what I was just going to say. If it doesn't wave, it's probably vibrating at a higher frequency.
Yeah. Being a guitar player, I know these things. But bottom line is that this is the future discussion. This is the company that's got this product. They're ready to, that's been demonstrated already for demonstrating what they wanted to do. I don't know if you recall that TED Talk that I showed last time we did this, but I have it on it could be done. I could do that. David, I'm going to go to Sabina's talk first. David, what's up?
Yeah. A lot of the cost of upgrading power lines, a lot of the cost and time to upgrade power lines is getting all the permits and
the towers. That's what
approvals
this guy was.
for the towers.
This guy was talking about. The towers can be reused. You don't have to reuse.
Exactly. If you can reuse the towers and upgrade the capacity of the carrying line, even though the cost of the wire itself may be much more expensive, it may be much cheaper to just upgrade an existing line than it is to put in a whole new system.
Tom Trice.
Reusing existing towers can be a legal mess because the permits were issued for usually in great detail of what was to be done there. And if you propose to change that, you essentially have to pull a new permit. And all of the people who were unhappy that you got the permit in the first place are now going to get a second bite at stopping you. At least according to my little brother, who does this for a living. He really prefers underground cables.
That's kind of the biggest challenge that America has compared to some other countries is that, I mean, if you look at, for example, the Caltrans train from LA up to San Diego or San Francisco, or I mean, regulations and legalities are basically the best thing and the worst thing about improving American technology.
Mm-hmm.
I mean, it's kind of what this. I mean, if you want to know why Elon Musk is so friendly with the Republican Party, and I'm going to say that, is that when he came to being recognized as a American car company that was doing American electric vehicles, Biden left him off the list. Does anybody remember that?
Mm-hmm.
Because he was he was non-union, which has
It was left off the list, doesn't really cover it. Pushed off the list.
Blackballed?
and the reason why Elon left the Bay Area is because there was so much regulation going on in San Francisco, in the San Diego area, and that that kind of restriction. I mean, I think that because he works with Chinese, and the Chinese are very good about saying, "The hell with you, we're going to build this railroad, whether you like it or not." I think that, and I'll point out something else about that historically. If you go back to the improvements that French and the English and all these European countries did, and these cities did back when they figured out how cholera was being fixed by fixing the sewers, it wasn't very nice for the common person, the poor person in that city whose property was derailed and so forth. Or even in the Minneapolis, if you look at where they decided to route the freeways, it wasn't exactly the nice parts of town that got torn down, but the not so nice parts of town and so forth. Well, I mean, I'm just saying that's the kind of problematic issues that you have. Or even if you're going to route if you're going to route something like a pipeline or a highway through something considered to be sacred land from the Native Americans. I mean, I'm not trying to point out the way to do this. I'm just saying that these are the kinds of things that happen. Go ahead, Dean.
I was going to just listen today, but when you guys start pontificating about California, and I have 2 PhDs in California compared to you guys, just because I've lived here, right? Yeah. And first of all, you cannot take a train from San Diego to San Francisco. You can, but you're going to get on a bus because some of and whatever. But yeah, the regulation, good Lord, and what I think it was Tom. Yeah, well, now you open up the permitting process again, and Katie barred the door. Lawyers are getting rich, and yeah. But the reason this is where I piped in. The reason Elon Musk was left out of the conversation is, and you said the E word. I didn't bring it up. I was not going to talk politics. Stanley chose to do that because he is a scumbag that doesn't believe in any government regulation whatsoever. Full laissez-faire. He won't submit his cars for HTSB or whatever the heck it is. He doesn't think the government has any business regulating cars, drugs, food, or anything else. So he is way, way fell off the libertarian edge of the spectrum in my mind. All right, I'm gonna mute for the rest of the meeting, I hope.
I don't want you to mute when we get to the Salton Sea discussion.
Well, hey, how long is it gonna be? I can drive out there and take pictures.
Okay. No, I already have a photo I used for it. That's like that. Thank you.
Yep.
Tom Walsh.
When we're talking about cables for transmission of electrical power, I have a little bit of experience in my neighborhood. I was several times a year I would lose power due to storms and so forth when we had lines strung on poles. When they buried the lines in my neighborhood, it was so bad that I bought my own generator for backup when we had problems. I haven't had to use it ever since they buried the cables in my neighborhood, and it wasn't an intrusive process. I mean, maybe for a short time, you had to go down the left lane of the road instead of the right lane or something for something in the neighborhood, but it wasn't an intrusive thing. So, in my opinion, burying cables is much better than stringing them up and exposing them to the elements and all sorts of things that could happen to them. If you're in an earthquake zone, it might be a different thing. You might not want to bury stuff then, but otherwise, I think that's definitely a superior solution.
David, and then I do want to get some videos done. I don't want to be too.
At approximately 3 times the cost. Just throwing that out
On
there.
the other hand, you save money by not getting your power interrupted.
This is true.
Society saves money.
There was a proposal to do a national grid of interconnect about 10 years ago. And as far as I know, that's being done in other countries, but it's not being done. It's not been, do we want to say adopted yet?
Real quick, so overhead lines are not subject to damage in an earthquake? Oh, I've been through 15 earthquakes, my friend. Yeah, and underground roads, they all, one collapses and the other collapses. Depends on what kind of collapse you want. So yeah, I mean, we are not in control totally. Ask the poor people in Bangkok right now.
Yeah, so buried cables might not be any worse than cables on poles.
Well, the repair on overhead is actually much easier. Yeah. You can set the poles, you can restring the wires, etc. Pull in a new cable and dig new tunnels and all that. Anyway, I'll shut up. I promise.
We'll skip the good news from Sabina. Any questions or comments? She confirmed my 10x discussion about fractured rock versus unfractured, and also that there is a elevation in the growth of geothermal over the idea of hydropower. Or geothermal, according to Cindy Taft, is the new hydropower. Go ahead, Dean.
Yeah, real quick, a lower hand, thank you. Something that relates to Minnesota. This is years ago. I was watching one of those This Old House kind of shows where they were building a, quote, summer cabin up Minnesota. And see, geothermal doesn't mean lava. It doesn't mean magma. It can mean a warm earth 365 that's at 55 degrees. And and they drilled down and they did a closed loop. Unfortunately, they ran into some a glacial bedrock or something, but they blasted their way through there. They were going to do it no matter what it cost. And yeah, they went down, and so they are using that as a heat sink for what's the word? Heat pumps.
Yeah.
They were able to make this really nice cabin extremely efficient, just using the 50-55 degree earth.
Yeah, yeah. That whole heat pump geothermal standard is I mean, it's kind of costly for a private residential to do that, but the payback is there.
Yeah, and it's not costly if you do it on a community basis. And I've seen that where they do one closed loop and then they distribute that to 50, 100 homes. So it's much cheaper to drill one big A well than it is 100. Infinitely, well, a lot cheaper.
The next video I'm going to show, David, I'll get to you in a second, is going to be on the Quay's technology, fusion technology. Go ahead, David.
Yeah, Carleton College put in a ground source heat pump for their steam system. They used to heat all of the college buildings with steam 100 years ago. And when they upgraded that system, they put in a heat pump system with a closed loop grid. One of the criticisms of the big centralized power systems, we really didn't go through much of it last week, but Rethink X discussion of nuclear applies also to geothermal large systems, which is to say they take a lot longer to build than small systems like photovoltaic. And there's a cost associated with large systems. One of the advantages of solar photovoltaic is that you can do it in small quantities. And so if you do a lot of it, as the demand is there, there's not nearly the investment risk that we would see with large system installations.
Tom Walsh.
I'm just wondering if there have been many studies of the ecological impacts of fracking for this purpose. For example, creating sinkholes or polluting groundwater, things like that. Have people looked into those kinds of effects?
Yeah.
Well, that discussion comes up, and I think maybe some of these videos will address that. But they're not, if you say polluting, they're not using anything but water.
Yeah, but we're introducing holes into it and fracturing the bedrock that protects those underground reservoirs and possibly allowing stuff to be introduced there in other ways, even if you're not pumping crap into it.
Yeah, I get that.
And I think and we are running that experiment even as we speak, or we're going to be, just like we ran the experiment on DDT. And unintended consequences. We don't have any more birds, or we won't soon. So
what I was asking is, can we actually try to determine the consequences ahead of time?
With today's technology, I think
been looking into it, those side effects very
much. With today's technology, I think they can model that. I hope.
We have no the aesthetic of that argument is really the same as saying, well, let's think about the air pollution with cars, like lead poisoning in cars back in the 50s and the 60s, or even back in 1907 or 8 when they decided to go with gasoline as a fuel. That idea of polluting the air was sort of just put to a back burner, and it gave us 70 to 80, maybe 120 years of prosperity. And now we're starting to decide to steer the ship to the left instead of to the right. So, I mean, obviously it's open for study, and it should be, but the idea that every single plot of land that's being used for possibly generating energy is going to be a critical resource for water and stable land. If you're not going to be doing anything that you need, that you care about on that land, that the risk, maybe the benefits outweigh the risk. I don't know.
Well, when you're looking at prosperity that these things provide, such as gasoline engines and so forth, that's the first order effect. But the second order effects could actually be more widespread and costly than anticipated. And I think we need to be a little more proactive to try to determine ahead of time if there's a net negative as opposed to the immediate positive.
I mean, my biggest concern with the Cindy Taft stuff with the SAGE geothermal systems is in my mind, and I'm kind of thinking, are we getting gaslit, using the word, by the oil companies to put another stall on doing anything about their business by making it look like they're virtue signaling to the environmentalist groups, oh, look what we're doing. We're going to give you this geothermal using our old drills and our old stuff that we don't care about anymore. I mean, I doubt seriously if Exxon or Mobil is going to design new drills and new technology that make this geothermal project work. It's going to be their backlot stuff that they're going to be using. That's with the exception of maybe one example that Cindy described as a new pump that was designed specifically for this geothermal project. I don't know. But I want to get into the next one is on fusion technology being used for drilling. This is the Quay's energy discussion.
5 seconds. What I gleaned from our previous thing is that for this fracking, cracking business, the drills is the same technology, but they have to be much, much larger than what they do for petroleum fracking. I believe that's true.
Sorry, I was muted. Dean.
Yeah, I was. Yeah, everybody was muted. I have a dumb question and then an observation. Where does the vapor go?
From drilling?
From vaporizing this rock at 300 million miles down. Yeah.
No, it comes right back up the hole.
Oh, okay. And what do we do with that vapor? Who knows, right? All right. And then the other comment is that, well, this is going to require serious government funding. So let's add another 4, 8, 12 years to the equation, because that funding is not going to be forthcoming.
This might seem like a silly question, but I'd like an answer if possible. If we're drilling that deep and getting closer to magma and that kind of thing, would it actually cool to some extent the center of the Earth? I mean, could it affect the core, the spinning core, which creates our magnetic field, which makes possible life on Earth because it diverts the cosmic rays? I mean, there are all sorts of effects that we can consider, and this is probably kind of a
that seems like
probably be very negligible, but I'd like to know.
That seems like a ridiculous question, but the fact that you, having a doctoral in physics, is asking it, it scares the hell out of me.
So yeah, I suspect when they're talking about this being a source of possibly all the energy that we'd ever need, then we're talking about doing a lot of this. And so I'm just wondering what kind of effects this could have
Right.
on that.
It's a classic Kantian question. What if everybody did that? And there were 17,000 holes every 20 miles. Yeah, whatever.
So we don't
I
have
don't
an
know. It's
answer.
kind of like saying that the star is going to collapse someday and wipe us all out. That's true, but that's a couple of billion years from now.
Yeah, well, we're talking decades, not
Okay.
not trillions of years.
Yeah.
David,
My guess is that the um, DARPA-E, when they looked at that, did some calculations and they weren't worried too much about it. But there is at least one or two other issues that are, to my mind, a little more immediate and open up similar questions in terms of difficulty in achieving 10 cents a kilowatt hour from this kind of a program. Specifically, the glass walls that you create. Oh, by the way, when you get the vaporized rock out the top of the hole, you have to manage to get that off to the side away from your microwave reflector so that you don't basically vaporize your gyrotron. So there are some, shall we say, technical issues that he finessed in his discussion. The one that concerned me is these glass walls 2 kilometers to 10 kilometers deep. They have to be sealed and they have to maintain that seal. Otherwise, you've dug a water well and the water well will eliminate the possibility of heating at the bottom of the hole. You'll just heat the water that flows into the well.
well, he did say that the super hot water that's at the bottom of that well will elevate itself up and then turn to steam, and it's a 1,600 times change
Yeah,
in.
but that's after you get the hole drilled.
Yeah.
If you fill the hole with water, you can boil water till the cows come home and never do any more drilling, okay? So you have to seal the wall. And when you talk about a 2 to 6 inch or 10 inch diameter glass tube, 2 kilometers or more long, that requires considerable geologic stability to keep from cracking the wall. Okay?
Sure. Dean?
Yeah, to W. Tom's comment, what about, the coming, when we're messing around with the Earth's core, what about the coming? Because it is coming and it has happened before and they don't know when. Welcome to San Andreas, welcome to Yellowstone, flipping of the poles. And that's a real thing. There's already signs that we are moving towards another flip of the poles, whether that's 4,000 years or 40 years or 100 years. I've never heard hard numbers.
If I could respond to that real quickly, yeah, they're saying it's getting close to flipping. I don't know what close means, but looking at past geological effects of poles flipping, they haven't. People that have looked into it don't say it's a huge deal. So I don't know what that means, but we'll
Does it mean
still
that the
have
water
it,
spins the other direction? When you flex your stool, does the water go the other way?
It
wouldn't
has.
affect that.
I'm sorry, it has a huge effect on navigation, et cetera, or can, unless you insulate yourself from that. A huge, huge effect.
Well, the magnetic pole has been moving quite a bit.
And the natural world.
It
As
was in
every
northern Canada.
migrating butterfly and everything else depend on that magnetic North Pole.
The North Pole was in Canada, straight north of Minnesota.
Yep.
Now it's almost right at the rotational axis, way up in the Arctic, and it's heading toward Russia.
Right.
So
And we are like 17. It's growing in my lifetime. We were 13, now we're 17, 17.5 degrees off true and compass here in San Diego, and it's real.
yeah,
Right.
but as I say, the effects of that, I don't know what they're going to be. Geologically, they haven't seen huge effects as far as life.
Geologically, a monarch butterfly is not a geological species.
Exactly. Yeah.
Just a question, kind of, and a comment. I don't think, I'm wondering if any of the condensed material from the rock, it's got to condense somewhere. That's what's making the glass walls. I don't think any of it's going to make it to the top of the well. I cannot imagine that. But maybe, I mean, yeah, it'd be really hot stuff at some point. I don't know.
Yeah, it's really hot stuff at the bottom of the well, and as it builds up all the way up the glass tube on the inside, you keep vaporizing it with the
Yeah, that's what makes the glass tube.
microphone. Yeah.
Yeah,
But
that's what's making the glass tube.
As it condenses, you basically have to hold the center of your waveguide at rock vaporizing temperature. And the pressure of the vaporizing rock blows all of the vapor up the tube, and you have to take that off and condense it somewhere else at the surface, or you're not going to drill the hole.
Well, the hole's going to get smaller and smaller as it condenses on the walls. It's not going to make it to the top. You think it'd make it to the top?
Well, you keep vaporizing. If its expansion is 1,000 times.
That's the water, not the rock.
Well, but that's a liquid to a gas. With vaporizing rock, you're taking a solid to a gas. So
Yeah.
if it's just 1,000 times, you're going to get that layer of condensing rock all the way up your waveguide.
Right.
And so as it shrinks down, it's going to absorb more of the energy and vaporize again and keep vaporizing. Essentially, you're talking about, if you're drilling a hole, you drill it, well, you saw the pictures of the rock, 2 inches wide.
Yeah.
Essentially, all of that rock vapor is blowing itself out at a high pressure because of that 1,000 times expansion. And as it condenses and shrinks the size of the hole, the energy vaporizes it again. So you are going to get vapor temperature rock out the top of the hole as you drill it. You won't get 10 feet without condensing that solid rock on the walls of the glass tube. Okay? So if
I can see that.
if
I
in fact
understand.
it shrinks the size of the tube,
Uh-huh.
the experiment won't get 10 feet before it stops. Does that make sense?
Yeah, I mean, it seems like there's a kind of a built-in limit. If it's condensing on the walls all the way up, that's a problem. Yeah.
Exactly. So we'll know very quickly that this system is not going to work if that happens.
Well, won't it just continue to recycle and hit the same, if the fill comes in, won't it continue to and then it creates a cycle, but maybe they still progress somehow?
That's what I'm saying. If this is a problem, we'll know it very quickly.
You may reach a limit, just like dulling your drill bits.
Yeah, that's a good analogy. Tom Trites.
This is a little bit like drilling a very microscopic hole into an M&M where the chocolate has already melted. And we're trying to extract the chocolate through the little tiny hole. It's a much bigger experiment than that, of course, but as far as the magnetic poles flipping and that's going to be interesting. There are these stories that keep coming out about how there are big lumps of internal structures in the earth that are rotating and turning around each other. And it might be that it is not the magnetic pole that flips, but the geographical poles that flip. Yeah.
No, I don't think it'll affect the spin of the Earth that much.
But this is really wandering into science fiction in my ideas.
Well,
That's what we're here for.
Yeah, no, I agree.
All right, Doug, before you guys get your questions answered, I have the next thing coming up. I'm going to promote my ideas here. This is David Greider's article about extracting lithium from the Salton Sea near San Diego. So try to think about that before we get too deep into our questions and answers. Dean?
Yeah, I'll try not to get too deep, pun intended. But this, and here's another pun, excuse me, this is rock science. But in the end, and let's hear it for Leibowitz on Big Bang Theory, if you didn't watch that show. So it sounds like a rock engineering problem that the rock scientists can demonstrate, and then the engineers then they have to, and I don't know. Yeah. I don't know. And by the way, real quick on lithium extraction, do you know about the current thing with there's a deep sea mining authority that every civilized planet on the earth has subscribed to except the US. And there are enough metals on the bottom on the seafloor, and it sounds like we may just go it our own way, but we'll see. But yeah, that's anyway, it is pertinent.
Eric?
Two things. As far as the effect on the Earth's total heat, it should be pretty easy question, I think, to ask one of the AIs what's the total amount of heat in the core of the Earth and its rate of creation by fission and whatever other mechanisms are going on there, and the amount that humans would extract, which I would imagine offhand would be minuscule compared to the total existing and being created naturally. But then the other thing is about flipping magnetic poles and so on. I wonder what those effects have had in the past and would have in the future on bird migration, for example, or I don't know, do fish use magnetic lines
Huge
on the whole
effects.
ecosystems?
If it doesn't happen in Darwinian time, it has huge effects. It has happened many times in Darwinian time.
Yeah, what about, and I don't read it. I remember reading anything in science or anything about the past effects on like bird migrations and therefore the whole biological ecosystem.
That's done if it happens tomorrow because they are magnetic creatures. Absolutely.
Yeah. Well, what's the effect on their migrations and the ecosystems and so on?
Yeah.
I don't remember reading anything about that.
But, yeah, and my point also was the numbers I have heard about, well, I love that comment. Well, this will be good for 200 million years, and fusion will still only be five years away. That was a comment in that, which
Yes.
is great. But yeah, that in the foreseeable lifetime of the human species, there's enough heat down there to
Yeah.
get us through.
And the amount that'll ever be practical to extract, will still be like what you said,
Right.
the most 8% or something ever.
Yeah.
How
We'll be riding Musk ships to Mars by then, probably.
how well can you guys see this article? Do I need to zoom it in a little?
It's fine.
Okay, I'm a terrible at reading, but geothermal energy has long been the forgotten member of the clean energy family, overshadowed by relatively cheap solar power and wind power, despite its proven potential, but it may soon change for unexpected reason. Geothermal technologies are on the verge of unlocking vast quantities of lithium from naturally occurring hot brimes beneath places like California's Salton Sea, 2-hour drive from San Diego. Lithium is essential lithium is essential for lithium-ion batteries, which power electric vehicles, yada, yada, yada. As geologists work through the geothermal brine, energy policy scholar believe this technology can bolster the nation's critical mineral supply chain at a time when concerns about supply chain security is rising. So, Dean, does this look familiar to you?
Muted. Yeah, it looks very familiar. Been there, saw that.
Elmore geothermal plant. Enough lithium to far exceed today's U.S. demand. Geothermal power plants use heat from the earth to generate a constant supply of steam to roll turbines and produce electricity. The plant's operating, bringing up a complex saline solution located far underground, where it absorbs the heat and is enriched with minerals such as lithium, magnesium, zinc, potassium, and boron. All of those fairly desirable.
Yep.
Geothermal brimes are concentrated liquid lift. Geothermal brimes are the conceptual liquid lift after heat and steam extracted as a geothermal plant. The Salton Sea plants, these brimes contain high concentrations, about 30% of dissolved solids. If test projects now underway prove that the battery-grade lithium can be extracted from these brimes, brimes cost-effectively, 11 existing geothermal plants along the Salton Sea alone could have the potential of producing enough lithium metal to provide about 10 times the current U.S. demand. Now, I'm going to go ahead. I've got this set up from a video that I can watch on YouTube, but I'm going to see if it'll actually play here for you so you can see this. So you can see that the brine is coming up. The top half is spinning the rotary for the actual production of power. Then the brine actually gets channeled into another chamber where it gets extracted so that the brine can be, the salts can be So we're killing two birds with one stone here. And I want to jump down here to another video.
There's a new ambitious plan to turn the Salton Sea into a hub for lithium. Now, it could bring an important emerging industry right into our backyard, which means more money, more jobs. Our Nico Payne has the story.
Yeah, lithium is so vital, some are going so far to call lithium the new oil. And the possibility for huge profit is drawing investors' eyes right here to the Salton Sea. Deep beneath the Salton Sea lies geothermal activity, and nearby geothermal plants turn that heat into energy. Now the state of California, lawmakers and investors think there's a way those geothermal plants can produce something even more valuable, lithium.
We have the largest deposit on the continent of lithium minerals to be able to supply the world and its demands and needs.
We have reserves for over 35% of the worldwide lithium that is needed. So that's a huge source.
As countries set ambitious climate goals, one of the biggest things that will help reduce their carbon footprint is switching to electric vehicles.
California is trying to divorce itself from the fossil fuel energy by 2035, and they want to electrify every vehicle.
A key component of the batteries in those vehicles is lithium, making lithium and not oil a natural resource that will be in high demand in the coming years.
Right now, there's a long list of positive things related to lithium opportunities at the Salton Sea.
The conventional ways of extracting lithium use a lot of water and can be bad for the environment. But the process that would be used in the Salton Sea would be different.
It is a byproduct of the process of generating geothermal energy in our region. It's very different than the traditional mining practices that we can think of when we think of lithium in China, lithium in Chile, Australia.
With big name investors like Michael Bloomberg and Bill Gates looking into lithium projects, lawmakers are asking for more transparency as the projects get closer to becoming a reality.
The big name investors should tell us that this is real. They've been in the region for the last 10 years doing research and development. More recently, the Department of Energy funded a $15 million grant to one of these companies that will actually build a demonstration plant.
Another priority, making sure the economic benefit stays in the region. The Eastern Coachella Valley and Imperial County have seen double-digit unemployment rates.
I've been proposing, and I would love to see this happening, opportunities, pipeline opportunities for young people to get the training, so that we don't need to bring labor from outside the area. I think it can be a game changer in the communities around the Salton Sea for many reasons.
Now, the possibility of lithium extraction would be a financial game changer, but at what cost? We'll continue following this story as we talk to local environmental justice advocates, sounding the alarm over the worsening health crisis near the Salton Sea. Reporting in
Questions or comments? Go ahead, Dean.
Yeah, this is 40-year-old, 20, 30, 40-year-old. This is on our local news at least 3, 4, 5 times a year for the last 10, 15, 20 years. And of course, there's the political side and all that, and the environmental, what's gone on with the health of people as the Salton Sea shrank and all that rigmarole. But yeah, it looks very, very promising. And that 10 times number, and I've heard that number, that site alone could replace the batteries in every single electric car on the planet today, or certainly the U.S.
Warren.
Yeah, I think, however, we'd have to get rid of a lot of environmentalists and lawyers in order to produce any batteries here. It's not going to happen.
Oh, because politics, liberal politics may win out, as in just like it did with Indian casinos. We have 13 in San Diego County, different tribes. So that the need of these people to develop themselves could trump, pun intended, the we'll see. it's all politics. Sorry, folks.
Well, it's also a question of economics. If it was very attractive economically, it would be happening already. The fact that they're not advertising, they're not applying for permits, et cetera, suggests that it's probably not nearly as cheap as investors would like to see.
When did politics and money get separated? Yeah, it's more connected than ever.
Okay, I've got a, I want to spend a little bit more time with Fervo. I haven't spent much time with Fervo. We spent time with Quays. So this is a discussion of Fervo's process. And I'm going to make sure I got this shared.
So Fervo uses oil company style fracking, right?
Yeah. I've got a little bit more on that as well. Is there anybody want to discuss that? Did you hear him tell you that he was hoping to keep the people that have talented drilling skills in the oil industry a longevity into their job skills? I have no personal problem with that, but that is obvious. That's why I'm a little bit concerned that there is. I'm not sure how real interest there is in this from the oil companies, because I doubt seriously that they're getting the kind of profitability from the geothermals they were getting from the extraction of oil.
Yeah, I'm next. F the oil companies. I know the Roughnecks, etc., are interested because they know what they're doing there and they want good paying jobs and all that. So I don't give a what did my grandma say about the oil companies. I do care about the people that have been employed in them. But now what I picked up on was that Tim, bless his little vulture techno-capitalist heart, he discovered geothermal. Oh, really? What year was that, dude? You know, when I discovered geothermal, in other words, it dawned on him, I guess, you know.
Okay, I got one here. If you pull down my, if you're interested in this, you want to pull down my, if you haven't already, pull down my Word doc with all the files that I've collected on this subject. It is incredible. Give me a second here to get the
Geothermal company.
Damn it. Oh.
Hey, Stanley, can't hear you. You're muted.
golly, all this conversation I've been doing has gone nowhere. Wanted to find a graphic that showed the two drills that were next to each other. They went down and off to the side, and one of them was below the other. And what I wanted to mention was that instead of having two wells that are fracked between them and they're getting a horizontal transfer, you can also have wells that go down and off to the side, one below the other, and then the one that below gets the pressure and the one above gets the outcoming heat, which comes back. Thank you, Dean. I'm sorry for the finger dance here, but the you get a It's a transfer, vertical transfer of the fluid rather than a horizontal transfer of the fluid. Dean.
Yeah, so oh, I just muted myself. So surprise. So the 7 to 100 year permitting process for is 2-3 years for oil companies. I wonder why.
Well, I think oil companies are trying to I'm going to use the term virtue signaling. I don't know. We'll have to see I mean, for example, do you remember a technology that was kind of talked up, got me excited, where you would stack blocks and they use gravity to create energy? Does anybody remember those? That was maybe 5 to 7 years ago. That was kind of a hot topic. What happened to those? Nothing, apparently.
Stan,
Actually, they're building them in China.
You missed my well let's go there. You missed my point, Stan. As in big oil, big pharma, big whatever owns Congress, has always, will always, you know, and especially now after that Supreme Court, money equals free speech. Dollars talk as loud as I'm talking right now. So yeah, it's very, very political, or it's beyond politics. It's founding fathers are rolling over in their grave. I'm going to join them soon, I hope.
I've only got one hope for this next 4 years, and that is that Trump's attempt to stamp out renewable energy will only give it more viability. That's a weird hope. It's like telling a child not to pinch a zit, but it seems like when you do pinch a zit, that the zit goes away really quickly. So I don't know. I don't know. Maybe that's a bad analogy. Sorry. But go ahead, Dean.
A very bad, gross analogy. Thank you for that.
Go ahead, Eric.
Yeah. Stan, did you come across anything on the economics of extracting heat from Yellowstone? I mean, it's amazing to drive through there and see all the, you know, heat coming up through the ground. And
I have no idea, but I'm sure that there is probably some pushback. For one, it's a tourist attraction. Two, it's probably sacred Indian ground. I mean, there's all kinds of ideas. I mean, I know. Do I have the answer? I'd have to do some research. Eric, you could probably do it as well as I could.
You wonder about this, all these, you know, sacred Indian and casino. Who won the Indian Wars? I mean, and secondly, I think it's ever more critical to get more accurate guesses about when fusion will be practical, because how much do we want to invest in all these other systems if that turns out it's going to be practical, you know, fairly soon at a lesser cost than expected. I'm hoping for DeepMind. I'm trying to follow DeepMind on this, and if they can give even any guess yet, more accurate guesses when practical fusion will be here. I'm much more optimistic because of their just the fact that they are researching it now and have their previous success in you know, protein structures and you know.
Eric, what could go wrong with practical fusion in your backyard?
I don't know. Why would I have it in my backyard? I don't understand.
Well,
okay.
I don't know if there's a NIMBY problem with fusion. Is there? Is there a NIMBY problem with fusion?
Yes. The NIMBY problem with fusion is talking about confining a plasma at 10 million degrees centigrade. And then using that energy to generate steam, well, maybe supercritical carbon dioxide, to turn a generator.
Well, helium.
We've talked about energy too cheap to meter from nuclear for almost 75 years now.
But AI was not at all useful until the last very few years, and it is continuing to progress despite all the
There's
publicity
a fusion
otherwise.
project that doesn't use steam. It uses a kind of like a regen braking system on a car, electric car.
And you can, I assume with fusion, once you got the steam, you can reuse all the rest of all the current system that uses steam from other sources.
That's right. You can. So those power plants are typically as close to the end user as is possible so that your line losses are as small as possible. In other words, in your backyard. The problems with fusion: one, we aren't there yet. Two, we've been 20 years away for 70 years. Three, they would be large power plants, centralized power plants. What's wrong with centralized power plants? Even if your technology is good, it takes years to produce a plant to implement it. You need the demand for that much energy. Electricity is allowing us to reduce the amount of energy we have to produce in order to give us final results that we want. Go back and look at Rethink X's discussion of nuclear power. They go through about 10 different reasons that nuclear power is not really as good an idea currently as renewable energy with batteries.
Tom Trites.
Oh my. We have a safe, reliable fusion plant already.
Yeah.
It's 8 minutes and 30 seconds away.
Or the one in the middle of the earth.
That's not fusion.
The sun isn't fusion?
No.
The middle of the earth is not fusion.
Oh, no. The in the long term, I think the medium term anyway, we're going to have to go to thorium. Good, bad, and otherwise. But the problem, well, there are many technical problems in all of this. But the biggest problem is the political problem.
Yeah.
Where everybody and his brother is trying to stop everybody else and paying their Congress critters to put up new rules to prevent the other guy's project from succeeding. It just really fills me with a sense of hopelessness. It really does.
Oh.
I get it.
Oh, one other thing. Yellowstone. I call Yellowstone God's backyard. It is a difficult place to build anything. You can't build modern highways there. I'm sorry. You can build them.
And build them.
Within years, the ground under them has shifted. And so you have to build it again. It is a great place to go and visit. I urge you all to do so before it gets totally spoiled.
Too late.
Yeah.
I was going there in the 40s and 50s, and I haven't been back since the 70s. And Where did all these people come from?
All over the world.
That's my presentation, but let's move
Anyway, but the political problems, I think, are going to be much more difficult to deal with than the engineering and science problems of getting good, reliable future energy.
Tom Walsh.
Next.
Okay, a couple things. As far as fusion, the problem is containment. You really almost need superconducting magnets to contain the ionized plasma inside the reactor, and so that's not a simple thing to do, especially if you're trying to do it on a small scale and produce something useful. It can. They are getting better at fusion reactions that last seconds, if not minutes. But we still have a long way to go to make it really practical. As far as Yellowstone, that's a very geologically unstable area. That's the worst place to do any kind of fracking. They're talking about a mega eruption, mega volcano being due soon that could wipe out large parts of the American West. So that's not where we want to do that kind of thing.
It could wipe out species, including us, possibly.
Well, yeah, I think that's a little extreme, but it could be very bad.
Talk to the dinosaurs, Yucatan.
As Tom, do you know if there's any research? What is the most recent update from the ITER project, the tokamak fusion reactor, ITER, ITER?
Well, I haven't really kept up on it, but I know both China, I think, and Japan, as well as somewhere in Europe, they're making pretty good progress on sustainable fusion reactions.
That's not going to be a that's never going to be a production facility. That's a test facility to see.
These are all test facilities.
Proof of concept R&D lab.
Right.
Stop.
Hugely expensive, probably more expensive than CERN itself.
Yeah, and it does strike me as ridiculous to create millions of degrees of heat to boil water to run a turbine. But the point of it is that once it gets started, it's supposed to be easy to keep it going cheaply because it uses hydrogen and helium.
Yeah, but the corrosion on the containment is a
containment. That's the problem, as I said.
Absolute technological nightmare.
Yeah, I think thorium. Tom Trites. I think I'm going to go with thorium as possibly the better medium.
Well, thorium actually is a kind of breeder reactor. There is a plutonium. I don't know about plutonium, but there is uranium that's also output from there. It's not as bad as our normal uranium reactions, but it's not totally clean either.
I think it's 233. I think it has a 233 component to it. Uranium. Carol.
Yes, I just wanted to drop a quick word on the NIMBY issue for fusion. And that is that controlled fusion is a poster boy for fail-safe. If you lose the containment, it fizzles out.
Yeah.
So you don't have that runaway heated plasma issue.
There's a lot of new fission reactors that claim that same. If it stops happening, it doesn't go. That containment issue has become a poster for a lot of fusion systems as well. Thorium and others. The small nuclear.
Fission, you mean?
I meant fission. Yeah, fission.
Yeah.
Well, yeah, it's two different issues. The containment is for fusion, is to maintain the reaction. The containment for the fission reactors is to keep radioactive elements from escaping. Two different things.
But
Chernobyl.
as I said, controlled fusion is kind of the poster boy for fail-safe.
But a 93 million mile safety factor seems to be almost enough. Somebody brought up the question of, will our current politics stop renewable energy? Solar, wind, and batteries is at this point the cheapest form of energy in the world. Lots of other countries are going to sidestep their production of electric power by going directly to solar, wind, and batteries instead of centralized power plants. Because solar, wind, and batteries can be done on a small scale, a medium scale, or a large scale. And they have not enough electricity. They need a little bit of electricity. You can justify solar, wind, and batteries very easily under those conditions because you can build them small scale. That's where the prediction for the next 10 years is that anybody who doesn't have electricity is going to go directly to those kinds of production of electricity. What we're going to do in the United States, if we manage to transition back to fossil fuels, is we're going to send a lot of our manufacturing abroad again, or we're going to maintain it abroad. China is developing all of the above. They're developing solar, wind, and batteries at a production rate higher than the rest of the world combined. They're also doing nuclear.
They're also building coal plants in Africa.
Absolutely.
Yeah, I have to leave pretty soon. I just want to say thank you for this for letting me do this presentation. I do have another video that we could do some other time on the issue of companies with data centers like Meta and Google and so forth, hiring fracking and small fusion reactors and so forth for just single purpose, single factory locations so they don't have to be dependent upon the grid. And that's coming, that's happening. Those contracts are already in the works. Cindy Taff described some in her discussion with Sage and so forth. But I've got to go, and I'll see you guys next week.
Wait, Stan.
Thank you, Stan.
Dad, if you have a chance today or tomorrow, call me about mini electric, please.
Okay.
Thank you.
All right.
Well,
Since I'm recording, I'll continue recording.
All right.
Even though Stan has
And
left.
I think I'm next. I've been next for a while. And I want to know how David gets a persistent hand, because when I talk out of turn, if I talk for 4 seconds or whatever, my hand goes down, but probably because he's the host. Yeah, and that's as it should be.
Yeah, my hand keeps disappearing too. I'm up first.
Yeah, well,
And that's your last name.
There are gestures that'll do that, but I've already done the experiment. If I yak out of turn and interrupt, and I talk too long, my hand goes away unless I get up there and click. But that's as it should
gone
be.
away again, and I didn't even touch it.
Perhaps it's because David does it infrequently compared to you.
There you go. You're allowed. Yeah. I mean, thank you, Professor, because Dean, are you getting tired of holding your hand up? Because we've already heard enough from you in class. Anyway, Yellowstone and Yosemite, that's another one. That's, sacred places. In Yellowstone, they wanted to turn into hydroelectric, and it almost happened. But Yellow, and they did the one further south, Inyo Canyon, I think it's called, which is almost a mini Yellowstone. And there's talks about reclaiming that. Anyway, Yellowstone is a sacred land for 5,000, 1,000, 1,200 years, and it was sacred to Teddy Roosevelt. And people thought he was nuts. and he created the National Park Service. Now, I have heard that you can mess around in the periphery of Yellowstone, without, I don't know, slant, all that technology, that you might be able to extract geothermal from the 800-mile cauldron, whatever the heck it is, under Yellowstone, and possibly. And so then all the ranchers that gripe about the wolves and whatever can say, hey, we'll just buy your land and send you a check for $250 a year for the rest of your lives. How's that? But yeah, I mean, yeah, but to David's point of solar, wind, battery. All right, so all the wonderful homeless people that we've invited out from Minnesota, well, guess what? They're in a nice tent or tarp. They have a solar panel. They have a battery. And that's how they charge their devices, because they have to have devices. And, I'll ask these guys, how do you keep your phone charged, man? He said, well, I got a solar panel and a battery at home, and I charge it at night, overnight, while I'm sleeping. Yeah. No, so that localized solar, and, they could do turbines because they live on the streets and the freeway. They could put up a turbine that would, when the semis to China go down to Ensenada, they could capture that wind energy. And so, yeah, no, that highly localized. Yeah, I wish we had more wind here. I'd put up a turbine, and then I'd really be able to charge my mini off my solar. Speaking of electricity, this is a total aside. I went to my cardiologist, and she says, oh, the good news is you've got 7.5 years left on your battery, on your current battery. I go, great. I'm going to go look at a car and sign a 60-year lease or 60-month lease or something. And she laughed. Then the bad news was, she says, hey, you unplugged your monitor. There's a monitor beside the bed that downloads via Bluetooth and then goes through Wi-Fi and uploads my data to some AI, and they look at my room. And she said, oh, that's unplugged right now. I go, really? You should have got an email or a message. Yeah, I get 100 emails or messages a day from Kaiser and whatever. And but anyway, she said, well, here's a piece of paper that may interest you, because I talked about solar, and it had to do with fiddling around, temporarily unplugging something, because the battery I knew would last for a week, and it's probably been 2 weeks. At any rate, SDG&E, bless their little hearts. I'm not going to ever worry about an electric bill again, because I have a pacemaker. I'm going to get virtually free electricity in San Diego. I'm going to get the baseline, you need this to stay alive, iron lung rate for my excess purchase. So a nickel a kilowatt hour versus 58 cents per kilowatt hour for overage. So
is there a way for Minnesotans to get in?
I don't know, but well, you got to live in a liberal state like San Diego. Sorry. I mean, like
pretty liberal.
Oh, it's very liberal.
I have a pacemaker.
Yeah. Oh, you do? Okay. I don't know, but look into it through your REI or whoever the heck does your power now.
Okay. Yeah. Eric, okay. Your hand keeps going up.
Yeah, as far as all the containment and corrosion and all those problems and all other kind of materials problems, DeepMind is already, last I saw, it's already discovered about 400,000 potential new materials. The bottleneck's, of course, testing them, but I've seen automated labs and video documentaries that they're doing hundreds a day, synthesizing and then basic testing of these new potential materials. So that's going to impact a lot of things in the world. I don't know how fast, but including fusion, which seems to be a lot of it, a lot of complex computations of all these variables at the same time, which is exactly AI's forte, and it is progressing week by week. You see the parameters. I watch the news, and there's like dozens of different tests of AI, and they keep leapfrogging each other week by week.
Yeah, AI
Right.
is particularly good in medicine, folding proteins and stuff. As far as containment of fusion reactors, that's magnetic, basically.
Yeah, but they're already moving on from protein folding to synthesizing a whole cell now. Or
Yeah.
modeling a whole cell, I should say, not synthesizing.
Materials for fusion reactors probably are important, but what's most important is the magnetic field, which does the containment of the.
And they can do the complex computation. There's hopefully a lot better in the future.
That's just part of the problem. There's also the conversion of the extraction of a little energy without putting out the flame,
Without what?
putting out the fire.
Oh.
And I think I'm next. And Tom, as goddamn brilliant as you are, if you can tell me the problems that AI may or may not solve in the future, then you're not a futurist, you're Nostradamus. I mean, I don't think we know. Right?
Could be a lot of stuff.
Who knows?
And it could. We also know that AI sometimes gives the wrong answer. So.
Oh yeah, it could be a lot of good stuff and a lot of bad stuff, just like everything.
And it's they're starting to deceive people too, which is scary.
Yeah.
Yeah.
Deliberately deceive people.
A whole nother.
But that's a whole nother presentation, I guess.
Yeah. Carol, go ahead.
Yeah, a quick question for you. You had mentioned something about earlier about controlled fusion being a great idea because hydrogen is a cheap fuel. Don't I remember that the controlled fusion people are using isotopes of hydrogen, deuterium or tritium, and them ain't cheap.
Well, they're produced actually in other reactions, but yeah, they're not plentiful like simple hydrogen. But
yeah, but don't I remember that
with extra neutrons in it?
At least the laser ones are using like deuterium or.
Yeah, I believe so.
Yeah, so we can't just say hydrogen is cheap.
But the amount of energy that's produced when hydrogen fuses to helium potentially could reduce the life cycle costs of that energy such that it would even justify using a neutron source to create heavy hydrogen out of regular hydrogen.
Yeah, well, as opposed to extracting it from seawater or.
Exactly, yeah. But those questions really, there are people who will invest money in that kind of research, but the potential problem with all of the big centralized power plants compared to solar, wind, and batteries is that you may end up building a stranded asset. The only way large centralized power plants make sense is when you figure the cost and the life cycle. And the cost.
And the distribution costs.
Absolutely. And the life cycle costs of centralized power plants depend on them being economically viable for the life of the plant, which is typically 20 to 50 years. The problem we have right now with electricity demand in the United States is that we're still using it at something like 30% efficiency for transfer from original fuel to end-use product. And that number has been getting a little bit better, at maybe 1 or 2% a year, for the last 10 years. That's why our electric demand has been level, if you look at it in this country for the last 10 years, is that we've been getting a little more efficient about our conversion efficiency. There's no reason to think that that conversion efficiency is going to change over the next 20 to 30 years. So the demand for electricity in the United States could be met by that conversion efficiency rather than new production. So even if we double the amount of end-use electricity we want to use to run our computers over the next 20 years, we may be able to produce that electricity more efficiently. So you have to be economically viable to build a centralized power plant, to do it with a centralized power plant instead of solar, wind, and batteries.
Yeah, just to answer Carol a little further, the deuterium lithium reactions in fusion reactors can, did I say tritium? I said lithium. Deuterium tritium reactions, fusing them produces regular helium plus a neutron. To get the tritium, though, that's pretty rare, as you said. But that reaction, if you use lithium as part of the containment vessel, that can help produce the tritium because it can donate neutrons to the hydrogen. Okay.
Very clever.
So lithium is important also in fusion reactions. So this idea of gaining lithium from the what we were talking about earlier, from
Salton Sea
plants in the earth, and the water that comes up, especially near San Diego, is probably could be helpful also for fusion reactions.
And okay, my understanding is, and correct me if I am wrong, that it is the laser generated reactors that require deuterium and tritium. The tokamak type reactors just require magnetic containment.
I don't know if the tokamak uses deuterium and tritium or just plain hydrogen or not. I would guess it uses deuterium at least.
Now, can you look it up quickly? I had thought that there was that was a big difference between the laser zapping reactors and the tokamak reactors.
Now you really are talking nuclear engineering, Carol.
Yeah.
Sorry, but
well,
it's underlying what we're talking about, isn't it?
That's nuclear physics. It's not my specialty. Mine was elementary particles.
Well, these are all elementary particles.
I got a question on particles. And I my hand lowered because I dared to go to Safari and go to Wikipedia to try to get information on what some of you may know. Deuterium, it is naturally occurring in water as H2O with a single molecule. But what is the percentage in seawater? 1/1,000,000th of 1%? I thought it was fairly high. I can remember in Minnesota, we put out fires, they did, with heavy water, right?
No.
So, no? There was just talk about it? That was my science fiction. I was reading, okay. But heavy water, yeah, you can't, yeah, I got you. But heavy water is a cool thing.
Oh, yes.
Yeah.
But yeah, I have no idea. I thought it could be harvested from the ocean.
Yes. Heavy water can be, that has been the normal way of getting
it. And what about tritium?
Same thing, only it's much less common.
Right.
they're very expensive to separate out. I mean, it's like trying to separate U-235 from U-238.
Right.
And
Use
isn't
a
tritium
centrifuge.
radioactive with a rather short half-life?
Yes.
Probably. And yeah, tritium triplets are more rare than twins. Yeah.
Yes. Remind me sometime when we have lots of time to tell a funny story from my youth that involves deuterium.
Not all of us have funny stories from our youth about deuterium. Real quick, and I got to go because I'm going to a concert and I want to be able to hear it this time tonight. Anybody have experience with iPod 2s with the hearing aid FDA approval or not, or I'm in uncharted waters?
Which FDA experiments? What were you saying?
No. Apple iPod 2s, the certain one, is FDA approved as a certified hearing aid.
Yeah.
And they have a hearing aid mode as well as a Bluetooth mode and all that. Yeah.
You hold it up
Try
to your
asking
ear.
Perplexity or Grok 3 real quick. I don't know if they're up to date on that.
Oh, and what are we doing next week?
David, do you have a schedule for next week?
Bob Kaufman is going to be presenting, and it's posted, I believe, if you look at the meetup group.
Yeah, because this is a fifth Saturday. I forgot.
Well, he was going to do today, and he had a conflict, so he's doing next week.
It would be nice to get a blurb up on meetup site.
I believe it's been posted.
Okay, because there wasn't one for this one, just the title.
Right, but it was a continuation from 2 weeks ago, so we didn't copy what was up 2 weeks ago.
Yeah, but people scanning sites might not have seen that one from last week.
Well, we had one visitor who joined us this morning who was new, and she left by 20 after 10. So.
Okay, I gotta go. 12:20.
Yeah.
Well, see you next week.
Me too. Bye,
Yep.
y'all.
Okay, bye.
Bye.
Leave. Oh, leave.
Have a good week.
We're working on it.